All right, good morning, everybody. Don't you dare hit fast forward on a single second of this. I should see 12 views on my manager when I log back in, right? Welcome to the Test 4 review. Let's get going. So, here's one oldie from lesson 11. Remember, if you are unaware how to set up the problems, always go back into the book. Look for the language that they tell you when you start reading and getting the picture in your mind. These are not supposed to be as easy as number problems. They're thinkers. So lesson 11 is all about sum plus some more equals a total. Easy enough concept, right? So here we are. Mr. Hines cleaned his car. In the front seat, he found 23 empty pop cans. In the back seat, he found 35 more empty pop cans. How many empty pop cans did he find in the front and back seat of his car combined? So, got the picture? What were some of the pop cans that he found? I'm hoping you're thinking he found some of them were 23 in the front. How many did he find in the back? 35 empty pop cans in the back. There is some more of the pop cans in the mess that is your teacher's car. And they want us to find out how many empty pop cans did he find in the front and the back seat of his car combined. There's your clue word, right? This is talking about the total. So maybe we'll use a C for car. Better than using an M for a mess, right? Let's go ahead and combine our terms. We got two numbers on the same side of the equal sign. And one of those that's so easy, it was hard for a while. It shouldn't be hard anymore. Let's combine 23 and 35. That's going to be 58. 58 equals the total number of pop cans combined. All right, that one wasn't so bad. Let's try another. Coming at you from lesson 17, the trickiest part of this is make sure you read all of it. There were 6 teams with 5 players on each team. Do you have the picture in your mind? How many players were there in all? But we're not done reading. Find the answer once by adding and then again by multiplying. So 6 teams, 5 players on each team. So I have 5 players on one team and another 5 players on another team and another 5 players and so on until you have all 6 teams with the 5 players, correct? All right, let's go ahead and add these numbers. I have 5 that I'm adding 6 times, right? However you want to go about finding that, hopefully you know the answer there is 30. But then I got to find the answer again by multiplying. Every so often I still have some students give me 2 different answers. If you're doing it once by adding and then again by multiplying, you still better end up with the same answer, correct? So I'm adding 5 6 times, so I'm going to times it by 6, aren't I? 5 times 6 is going to give you 30. I have the same answer. I'm just setting it up 2 different ways. One coming at us from lesson 6. What is the sum of 275 and 829? You got 2 tricky parts of this. First of all, do you know what a sum is? If you don't, it is both available for you in lesson 6, but actually I think that would be hard. I would go to the back of the book in the glossary and find out that sum is the answer when you add. The only other trouble I see ahead of us is making sure we read it correctly because it's all written out in words, isn't it? Make sure you read and double check. 275, and 829. Make sure you write nice and neat, showing your work. Nice, neat, vertical columns up and down, and we know sum is the answer when you add. And then just go ahead and run the addition algorithm. 5 plus 9, hey, that's got to be 14. I write down my 4, I carry my 1. 1 plus 2, 1 plus 7 plus 2, hey, that's going to be 10. So I write down the 0, I carry my 1. 1 plus 2 plus 8, that's 11, and I don't have another column here to carry it over, so I can write both of my digits. I can write 11 for a grand total of 1,104. All right, one problem coming at you from the fine folks at Lesson 16. If you don't know how Lesson 16 story problems are to be set up, feel free to look back in your book, right? You better find sum that you start with minus sum that went away equals what's left. Read each sentence carefully. You might read it 4, 5, 8, 11 times. These are not supposed to be as easy as digit problems, right? Because you have to read and you have to think. They are not giving you the digits. So let's take a look at our problem right now. There are 248 students at Dunsea's school. If 129 of the students are boys, they want to know how many are girls are left. How many are girls? Okay, so let's think. Some of the students that we're starting with. 248, because we're starting with all of the students, correct? And they eventually want to know how many students are girls. Well, if you're only counting the girls, the boys had better get out of the way, right? You better not have any boys left in the room. Boys, you gotta go. So the students that went away are going to be the boys. 129 equals what's left. We don't know what's left. Maybe you need a G for girls. Let's just go ahead and run the algebraic algorithm. Even though it's subtraction, it's one of those again. It is so simple, it's almost hard, right? We almost can't even say that anymore. These are getting easier every day. So we have a pair of combined terms here, don't we? I am not going to bore everybody running the subtraction algorithm on this because I don't want you to hit fast forward. So hopefully you can work out in your scratch piece of paper. Everybody has that capability. The combined term answer is 119. I did not underline the equal sign. I did not underline G. It's about that easy. Check out this one from lesson 12. I don't think anybody who grew up in North Dakota has a problem here. We are comparing -4 to regular 4. Well, what is warmer? A negative temperature or a positive temperature? Positive temperature is always warmer because it's the greater number. So -4 is less than 4. Check out this one. We are comparing 9 plus 9 plus 9 plus 9 compared to 9 times 5. I'm going to show you a couple different ways of going about this one. You know me, I always say get the answer and work it out, right? 9 plus 9 plus 9 plus 9, that sounds like it's 36. Compared to 9 times 5, that's 45. So, which way is the crocodile's mouth opening up? It's opening up this way. But I want to point out one other thing. Kind of ties into what we learned before. If you're going to add 9 4 times, or times 9 5 times, multiply by 5. Technically, you could just look at it if you really think. But right now, I would not advise that because I have some people, their biggest problem is just not looking at the problem close enough. And you could open the door for an easy problem wrong. Double check everything. So, also coming at you from the fine folks at lesson 12, you got to make sure that you are acquainted with what direction vertical is, what direction oblique is. And remember, oblique actually isn't just this way. That's oblique, that's oblique. Heck, that can be oblique. Oblique just means it's not vertical or it's not horizontal. Oblique is not a set direction. All right, here's one combining something you learned in lesson 2 and lesson 15. Think of 2 odd numbers. My advice, think small. Why work harder than you have to? I'm going to use 3, and I think I'm going to use 1 because it said to multiply them. 3 times 1, hey, that's easy enough. That's 3, right? But that's not where we leave off. We got to make sure to read, is the product odd or even? In this case, hey, it's odd, right? So we're not going to fast forward through this. We're just going to wait till I finish writing and get on to the next one. Check out this one. I didn't think I was going to put it on the quiz, but boy, I still have people, for whatever reason, making silly, sloppy mistakes. So I'm going to talk about it. 4 times 9 is 36. If you're fuzzy in any way, shape, or form, you can use a multiplication chart. I'm going to write down my 6, and I'm going to carry my 3 to the top. Most of the time when I see silly mistakes, I don't see people writing down their carrying numbers, or they're writing so messy they can't read. Then you go 4 times 1, that's 4, plus 3 more, hey, that's 7. And lastly, I go 4 times 3, that's 12. The other big mistake I sometimes see, people will put in their dollar sign and then they're ready to go on. But folks, there's a decimal point. There's a huge difference between $1,276 and $12.76. If you forget the decimal point, it is wrong. Again, I see some people, I can't believe it, still struggling with the subtraction algorithm. And I keep talking, but we found out what our mistake was. Some people are fast forwarding through my talks. So if you start off and you get it set up in nice, neat, vertical columns. Okay, can you start with 0 minus 3? The number on top has to be larger. So you go next door to your neighbor and he says, man, I got 0 too. I'm broke. Let me go talk to my neighbor. He says, times is hard all over. I got nothing too. Finally, 4 neighbors up, somebody has 5. So you cross out the 5, you write the 4 on top. You pay 1 to your neighbor. Neighbor has 10 now. He says, hey, I got 10, I can help you out. So 10 now becomes 9, and he pays his neighbor. Hey, neighbor, I have 10 now, I can help you out. So 10 becomes 9, and he pays his neighbor. Here's the sad fact of the matter. I still, just a couple days ago, had people crossing this out because they think they're paying somebody. Who is he paying? Nobody. There's no neighbor here. So you're going to start with 10. 10 minus 3, that's 7. 9 minus 9 is 0. 9 minus 2, that's 7. 4 minus 1 is 3. I have a decimal point that I bring straight down, and I better make sure to write in a $sign. Let's keep moving on. Check out this one coming at you from lesson 17. Make sure you're familiar with all 3 ways to show division. And I have a lot of people, especially right here, that still think you pronounce this 7 divided by 56. If it's in a division box, you read the number inside the box, otherwise known as the dividend, first. Anytime in your 5th grade career, you say the big number first. Later on, you're going to get into some times where you say the small number first. The dividend is always pronounced first when you're saying it out loud. So 56 divided by 7, 7 times what is 56? That answer should be 8. 25 is your dividend, 5 is your divisor, so your quotient is 5. Here in the old division bar, or later on you'll find out it looks like a unreduced fraction or unsimplified fraction. Your dividend is 36, your divisor is 4. 36 divided by 4, that's got to give you 9. All right, check out this one. I still have some people making a mistake, trying to multiply 3 numbers at once. Folks, you can only multiply 2 numbers at a time. I don't care how good in math you are. 9 times 4 is 36. So then you take that product of 2 numbers and then you multiply it by the third. 36 times 3, well, I don't think anybody could probably do it in their head, even though we've been practicing it during mental math. Maybe you can. If not, set it up on paper. 3 times 6 is 18. So I write down my 8. I carry my 1. 3 times 3 is 9, plus 1 more. Hey, that's 10. So I have 108. Check these out coming at you from lesson 18. And if you have a variable actually printed on your paper, I need to see the algebraic algorithm, right? Show your steps. We set them up horizontally. H times 5 equals 30. Okay, do I have to combine terms or isolate a variable? Hopefully you know you're just isolating your variable, kicking it over to the other side. I don't have to worry in multiplication if the first term or the second term is the variable. That's only in subtraction. So let's just go ahead and rewrite everything that's not circled. I did not circle H. I did not circle my equal sign. I didn't circle 30, but I did circle times 5 and I kicked them over to the other side. So I just want to use the inverse operation. The inverse operation to multiplication is division. So I'm going to change multiply to divide. Divided by 5. Last step, I just have to go and combine some terms because I have 2 numbers on the same side of the equal sign, and I better drop her straight down, right? So I have H is not underlined, equals is not underlined. 30 divided by 5. 5 times what is going to give me 30? Think of it in reverse, looking for a factor, and the answer is 6. Here I have t minus 14 equals 45. Do I have terms to combine? No, I do not. I am isolating my variable right off the bat. I'm kicking right, so that's pretty easy for us. But here's the one part that's trickier. Subtraction. Here's your first term. Here's your second term, correct? If you don't know what to do, on a subtraction equation, you had better turn back to lesson 14 because I wrote in red ink in everybody's book, if the first term is the variable, you still add, don't you? We'll talk about that in a second. So I have t. I have equals not circled. I have 45 not circled. But first term's a variable, I want to still add. Change subtract into add. 45 plus 14, now I have terms to combine, right? Two numbers on the same side of the equal sign. And I read my equation left to right. I have t equals 59. And the last thing I want to talk about when you're doing an equation and you're trying to solve your own problem, it is always a good idea to put the number up by the letter, maybe in your imagination, because, yeah, you should not end up with a number too small, right? If you ended up with 36, no way could you have started with 36 subtracted by 14 and equal 45. Because you know me, I'm not going to give you a fish, am I? You have to start solving your own problems. And lastly, we have lesson number 10, 213 plus L equals 649. The first time we started our algebraic algorithm. These are so easy for us now. No, Mr. Hines, I do not have terms to combine. I can start isolating right away. Look how nice and smooth my pen writes. I kick over to the right-hand side, even easier. I end up with L equals 649, and instead of plus 213, I kicked them so hard my plus sign broke. Remember when we did that shtick? Now we just know to do the inverse operation, right? And lastly, I have terms to combine, right? So L equals 436. Were you able to do that one mentally in your head like I was? I wasn't sure if I had to hit pause and work it out myself, but that actually was pretty easy to do. And that is the end. I highly recommend double checking everything. Remember, one math test is the same as 3 daily assignments. Make sure you put the time in. When you are done, I am insisting that everybody go and work on Math After Test 3. Even if you have a little bit of work left to do on Math After Test 2, I want everybody today starting Math After Test 3. All right, good luck.